Hey there, so this video is going to cover sections 1.1 and 1.2 for the in-class material for Math 093. And for this we're just working out solving really basic equations, and what I want to remind you of before we got started is that in terms of inverse operations, addition and subtraction are going to go together. So when we see subtraction, we're going to use addition to undo that, and when we see addition, we're going to use subtraction to undo that. And likewise, multiplication and division are going to go together. So those will be inverse operations, so one will undo the other, and we'll see what I mean by that as we go on here a little bit. And then the other thing was, when we're solving equations, we go in kind of reverse order of operations. And when I get down to about example 6, we'll see a little bit there. But for these first examples, we're just working inverse operations. So I'll cruise up to there. So we have c minus 5 equals 8. And so you can probably just look at that and go, that's 13. Yes, that's totally true. But we need a little bit more a way to solve these when the numbers get harder. So we'll do out some steps here. So since I have c minus 5, to undo a subtraction, again, that we would use addition for that. So we're going to add, oops, come on back, there we go, add 5 to both sides of the equation. So c minus 5 plus 5, those 5's cancel, and we have the c all by itself, and then 8 plus 5 is 13. And again, you can probably do that in your head, but the takeaway from this is when you see subtraction, you undo it with addition. So likewise, for this next one, 11 equals 9 plus p, it's not hard to see that p is 2, but when the numbers are harder, we need a little more structured way to get there. So since 9 is being added to p, I would subtract 9 on both sides. And that's the 11 minus 9. There's the 2 that we can just kind of see intuitively, but 2 equals p. For these next two, 3 and 4, so in both these cases, there is a number that is multiplying 4 times t, or negative 4 times t. So to undo a multiplication problem, we would divide. And we want to divide the sign and all because we want this to come out to positive t. So that tells me I need to divide both sides by negative 4. And then negative 4 divided by negative 4, that cancels. And 36 divided by negative 4, that gives me the t by itself. And that would be a negative 9. This next one is very similar. Let's just remind you of the double negatives. So this is a negative 11t, or negative 11 times x. And so I would want to divide both sides by negative 11. And then double negative, remember that makes a positive, so that's going to give us a 2 right there equals x. And that makes sense, right, because negative 11 times 2 would indeed give us negative 22. And then the last of the basic ones, so this is the end of 2.1 right here, is now we have x divided by something, and so the inverse operation for division is multiplication. So again, when we have multiply, we divide. When we have divide, we multiply. So for this one, let's multiply both sides by 6, and that you can think of that as 6 over 1 if it helps to see how that's going to cancel. And we'll do the same thing to this. I'll just think of that as a 6 because the fraction isn't helpful there. And now those 6's cancel out, and that leaves me that x all by itself, and negative 3 times 6 makes negative 18. If we put that back in the original, negative 18 divided by 6, yep, that makes negative 3. So we see division, we use multiplication to get rid of it. For number 6, now we have two operations, and so this is section 1.2. We have the 4 is multiplying the x, and the 2 is being added to the x. And so we want to, when we're solving equations, we want to work kind of backwards through the order of operations because it's like we're undoing the order of operations. So we want to add or subtract first and then multiply or divide second, and that's going to be pretty much every time. So first, and again, our goal is to get the x by itself, so you're looking here and seeing what do I have to do to the things around it to isolate x. So we will do our add or subtract first. So we'll subtract the 2 on both sides. And that leaves us 4x equals negative 32. And then we would divide out, since the 4 is multiplying the x, we'll divide both sides by 4. I'm going to have to figure out how to stop doing that as I make these videos. 4's cancel, and then I get x is equal to negative 8. And you can always check these by putting that back in. 4 times negative 8 would be negative 32, plus 2 gets you back to the negative 30. Scroll up. Similar problem, we have, our choices are, we have a 5 that's being, the x is being divided by 5, and we have a 3 that's being added onto it. So we'll start with our addition and subtraction first, and then go to our multiplication division second. So from both sides, I'm going to subtract 3. And now I have x over 5 equals negative 11. And then that 5 is dividing, and so we undo division with multiplication. So I will multiply both sides by 5. Again, if it helps, you can think of it 5 over 1 to see that cancel right there. And we'll do the same thing on this side. And then we have x equals negative 55. Decimals, nothing new, just worse numbers. So again, this is being, so notice this is a positive 54 right here. So to undo a positive 54, there is subtraction happening, but the negative is actually on the term involving the n, not the 54. So since this is a positive 54, to undo that, I'm going to want to go minus 0.54. I should be saying 0.54 there, sorry. And what I do on this side, I have to balance out by doing on the other side. So if you think of what this would actually be, this is 0.54 minus 0.54, so those have canceled, and that's going to leave me over here, just careful not to lose this sign, negative 0.15, oops, n. And then on this side, what does that make? It makes 0.108. And so now we have a negative 0.15 that is multiplying the n, so I want to undo that with division. And I want to clean up the sign and everything, so we're going to divide both sides by negative 0.15. Because when you do that, that leaves you just plain 1n, and that's always our goal in terms of the variable. And then we'll throw that in a calculator, and then that comes out to n equals negative 0.72. And then our last couple are using that same idea, but now there's some words involved. So for this one, we got statins are used to keep cholesterol in check. Top selling drug in the US. The equation blah gives the sales. So this is the sales of statins in billions of dollars X years after 1998. According to this equation, how much did people, yeah, it's kind of an interesting sentence. How much did they spend on statins, basically? So we're looking for the sales. We're being told the year 2016 right here. So that means we know X, and we're looking for S. So I could solve this around. I probably wouldn't. I don't think it's worth it. Something that we should look at here is X is the years after 1998. So if I go 2016 minus 1998, that's going to give me what my time is. So if we do that, that would be 18, yeah, it's 2, and then carry the 1. So that would mean that X would equal 18, for our time would equal 18. So plugging that in, we go 1.4. Again, we're trying to find sales, so that, and I know time. So we put an 18 right there in for the x, and then that equals 6.4. So I have a little bit of multiplication to do there, so let's get that cleaned up to a nice solid number. And if you throw that in the calculator, you'll get 25.2 equals 6.4. And then so we have s minus 25.2, so we would want to add 25.2 to both sides. And that will get that s by itself. So now we would have that would cancel, and we have s on this side. And adding those together, I think we get 31.6, yep, 0.6. If we're being official, that should be billions, or $1 billion. We'll skip the s. And then this last one, we have Dilbert recently hired a plumber to do some necessary work on a final bill. Dilbert was charged a total of $1,060. $220 was listed for parts and the rest was labor. If the hourly rate for the labor was $42, how many hours of labor was needed to complete the job? Okay, so first we're supposed to write the equation, and then after that we're going to figure out the number of hours. So let me see if I can undo pattern. It won't let me. That's cool. So in terms of the equation, we know the total is going to equal, let's see if I do that. There we go. Oh, I see what the problem is. Okay, we're just going to be stuck with that the way it is. Go back to my pen. So we know the total is going to be parts plus labor. And we know the total amount was $1060. We know the parts was $220 in parts. And then the labor is going to be, it's $42, and we want to use x as our variable. So it's $42 an hour. We don't know how many hours they worked, but we know for every hour they worked, that's going to add $42 to the bill. So for instance, if it only took 1 hour, right, it would be $220 in parts plus $42. If it took 2 hours, we would expect that to be $84 for labor. So that right there would be our equation. There's no kind of magic bullet to figuring this out. It's just thinking what makes sense. If I spent $1,060 and $220 was this, and the unknown amount's that, that would be our equation. So then we're supposed to solve our equation, part A, to find the number of hours needed to do the job. So let me recopy that down here. And we're right back to solving a linear equation. So we have the 220, which is positive, and so that means we would have to subtract that to get it over to the other side. And so if we do that, that will be 840. And then that cancels, and we're left with 42x on this side. And now we can divide out the 42 because it's multiplying the x, so to undo that we would divide. And throwing that in the calculator, it looks like we get 20 hours would equal x. And that wraps up 1.1 and 1.2.